Hello everyone. The motion technical support is coming. Here, bring motion control PSO function serious knowledge. There will be 3 parts about PSO. At first, let me explain what is PSO. PSO means position synchronous output function in motion control, or hardware comparison output. Through this function, it can output signals synchronously at high speed. Then, in real applications, high speed and high precision requirements in motion control or automation solutions can be met, which improves the efficiency and quality. And here, the first part is related commands to achieve PSO function. Now, let's begin. There are 3 commands: HW switch 2, move HW switch 2, and HW timer. The first 2 are used to select a suitable comparison mode according to exact applications. HW timer means hardware timing. It can be used together with the former 2 to use precision control and then output wise of poles. Perhaps someone will ask, move HWP switch 2 and HWP switch 2 are alike, the same one? Actually, their usage, methods, and principles are the same. The only difference is the one with move that will enter motion buffer and execute comparison in buffer. Okay, next see one by one. HWP switch 2. It is mainly used to set some comparison conditions, then control OP port to output signals consecutively and high speed. And the OP port must support PSO function, namely, hardware comparison output should be supported by used output. Otherwise, the command cannot be executed correctly. For example, ZMC46 can use 4 outputs to output PSO function, PSO signals. For ZMC460N, all outputs support. Therefore, we need to confirm which port supports PSO function before using. Then, confirm the position to be compared. There are also several kinds of positions. Generally, feedback position of encoder will be used as comparison position when there is no encoder. No encoder, we can use poles output. And this depends on a type. That is, if configured a type is with no encoder, M poles will be used automatically. If not, D poles will be used. We could see this. It shows comparison output. Essentially, it controls OP's continuous flip with the changes of the positions. As for this instruction, there are some attentions. Number 1, usually compare once in each system period, which can be checked through servo period, and the factor period is 1 millisecond. When we set poles wise, which should be bigger than system period, if encountering wrong output, check whether poles wise is too small. One comparison is not for all controllers. Some support several times. In fact, it indicates several OP ports all support PSO function, and then can output PSO comparison signals in one system period at the same time. Number 2, when we use precision output function, move OP, in program, it is better to use them synchronously in the different channels, except some high-performance controllers such as the MC460 M GMC 54 scan, etc. Number 3. Some modes need to call comparison position in table. That is, comparison positions are saved into table and then date is called from the table through the command. Therefore, do not modify table before completion. Number 4. When pose models are used, a type should be set as 4. Then, M-pose can be compared. Then, let's see its usage. From this, we can know there are many modes, and they should be with different parameters. Next, 2 typical modes will be shown. Here, Mode 1, Single Axis Comparison. These are parameters to be filled in. Mode 1, so fill in 1. OP none, fill in corresponding output port to be operated. OP state, output status of the first comparison position. That is, when comparison is triggered, the first port state is off or on. The default status is off. But when comparison point 1, it needs to output, so on or 1 should be set. Table start and table end means table range to be called. Because in this mode, we need to write all comparison points into table in advance. The last one, direction of comparison. It must be filled correctly. Please see right. It describes this mode clearly. See, we can set lots of table points, but it cannot exceed the max table size. Actually, it executes the table flip once when arrived at 1 point. For example, it reached point 1. It will open because of set on status. When in point 2, it flips to off. Point 3 on, point 4 off. When all points are compared, OP won't act. Here means when there is M-pose, it compares with M-pose, or compare depose. Okay, see one example for this mode. These are basic parameters to be set. When in initialization, close OP for avoiding wrong operation. If it is on, the first point won't react because point 1 will be set as on. Then, we save needed comparison points in table. Here, it saves starting from 0. And then, configure comparison. Use this command to stop or delete points that are not finished. Namely, clear it. Prepare for comparison. This set how to compare. 1 means mode. 0 means OP number. 1 means electrical level of the first point. This is high level. 0 and 3 means the called table range. And move positively. Then, when it arrived at set point, comparison will be triggered. The right shows captured waveform. It collects depose and OP changes. The scale of depose is 100, and we set it compares from 50. So this point is at 50. OP will open under HWP switch 2 control. When at 100.2, it will off. When at 200, all finished. So, no any comparison output. Except there is a new comparison command. Next, let's see mode 6, vector comparison method. It is more complex than Mode 1. Mode 6 doesn't use table to save comparison points, but it sets comparison gap of one period and sets pose wise of each period through command directly. Then see the usage. That is the grammar. The front three are the same as Mode 1. Vector start means vector distance is compared, namely current running vector value. But it is different from depose and mPose. Depose and mPose are relative distance. For example, when homing is finished, they are cleared as 0. If it moves 100 in positive, depose also is at 100. If it backs 50, depose becomes 50 because it is calculated according to its distance of origin. But vector move is a vector parameter. So for Mode 6, in above situation, it moves 150 units. Then this can be used in occasions that move forward and reverse. In the short, vector start sets which point start to compare. It can set the comparison is triggered after moving 50 or 100 vector distance. Repeats indicates how many times the comparison output compares. This parameter is very important. For Mode 1, the times is determined according to saved table points. But for Mode 6, it is set through this parameter. The last one, cycle this. It determines the gap between two comparisons. For example, we set as 50. Every 50 vector distance, it will trigger one comparison. Okay, see right. This shows how each command works. The red parameters are controlled by current HW-PSwitch2 instruction, and the origin parameters are controlled by HW timer. Specifically, it controls output pulse wise and times when arrived at each period trigger position. Let me explain the diagram. When it arrived at this point, comparison is triggered. Then, times of each trigger is controlled by HW timer. For example, it sets as 2. The period is 2. Output 2 times high electrical level, then no output. And this parameter also can control cycle time. This is one full cycle. And valid level output time of each cycle is controlled by this time. From repeats, we could know how many times the trigger controlled by current HW-PSwitch2. But after trigger each time, HW timer also can control several times output. So the total comparison times is confirmed by these two instructions. As mentioned before, Mode 6 uses vector coordinates. It can be composed. For example, if it is an interpolation motion, this is a resultant coordinate. Therefore, it can be used as single-axis motion and multi-axis interpolation motion. Then, let's know clearly from one example. These also are some basic axis parameters configuration. Vector moved. Initial position of vector should be set as 0 to ensure following coordinates are correct. Firstly, call the stop instruction. Then set Mode 6. Here, it starts to trigger comparison when at 100. Compare 4 times in total. Each comparison leaves 50 vector distance. Then, using HW timer to set pose wise. Okay, it's time to run. and waveform is formed. This 4 corresponds to 4 times. 100,000 means the period, that is 100 milliseconds. Divided wise is 50,000, that is 50 milliseconds. From time in horizontal scale, we can time-wise controlled by HW timer. Here, the pulse is 100, so this is position 100. This is 150, and this is 200. 100 the trigger point, and every 50 trigger once, which means HW2 controls the second trigger, third trigger. Here, 2 times outputs after each comparison, and it can be seen the trigger is well proportioned because it has one command, that is, the interval is 50. For mode 1, it uses table to set comparison points, so intervals of points can be customized. The last one, HW timer. It does timing, then controls OP high-speed inversion. Each controller has one HW timer. If we use one new parameter, former code will be cancelled compulsively. OP and move OP. Kinds of disk operations of OP switch, they will close HW timer pulses that are in running. In this way, it can achieve functions like PWM. When OP outputs, pulse output also can be opened, and when next OP outputs, turn off pulse output. Then, the function precision PW outputs infinite pulses can be achieved, and current remaining pulses can be checked from entering HW timer. For HW timer, cycle setting should be noted. That is, comparison cycle must more than system cycle. And output port, it must use OP that supports PSO function. Then see the grammar. At the beginning, mode configuration. Only 2 means open. 0 means stop former configurations. Cycle time sets cycle time. OP time sets valid time of each cycle. And please note, the OP time should be less than cycle time. Rep times means total repeat times. For OP state, it is different from HW2. Here, it is a reference state, off at first, then become on. It starts to do timing. The last one, OP num, output number. Right shows HW timer work principles. Its trigger condition is OP state. When OP becomes the state that is opposite to OP state, then instruction can be triggered to timing. Next, it outputs according to configured parameters. The repeat times depends on this. The example, basic parameters settings, turn off OP, 100,000ths. Valid time of each cycle is 50,000ths, or 30 times comparison output, and refer to off electric level. So we need to send one OP on command for triggering timing. At last, we see the waveform. 30 times outputs, and the interval of each output is even. Here, duty cycle is set as 1, 1. If we set a big valid level, output in waveform will be wider. And the total time is time of each cycle multiplied with total comparison times.